Next function we are going to see is the rational function. Rational numbers. What do you mean by rational number? A rational number is of the form p by q with the condition q not equal to 0. Same way, a rational function is a function of the form p of x by q of x with the condition q of x is not equal to 0. There will be a function in the numerator and there will be some another function in the denominator, but the condition is denominator function will not be equal to 0. For example, I am taking the function x square plus 2x divided by x plus 3. X square plus 2x divided by x plus 3. The denominator value is x plus 3. If x takes the value minus 3, the denominator becomes equal to 0. So what you have to do is we have to avoid minus 3 from the domain. Okay, so we can take all the real numbers except the minus 3. And corresponding to the function defined, we will find the range. So here we will see an example. I am going to take a a rational function. Y is equal to 1 by x. I am taking the function y is equal to 1 by x. Can you see the graph? The graph doesn't touch the x origin. 1 by x. 1 by x is not defined when x takes the value 0. That means when x is taking, it is clear from the graph that when x takes the value, the graph is not defined. Okay, so 1 by x is a rational function and the graph of 1 by x is given like this. It doesn't touch the x-axis, and you can see two graphs, one on the first quadrant and the another one in the third quadrant. These are not two graphs, these are actually the combination of the graphs of 1 by x. Okay, so the domain, can you define the domain? The graph is taking values except at the point 0. So domain is, otherwise you have to check where the function fails. That means where the denominator value becomes equal to 0. We took the function 1 by x. The denominator is x. The denominator becomes equal to 0 when x is taking the value 0. So avoid that 0 from the real number set. So our domain will be r minus z0. And range is those values of y in which the graph is there. And it is clear that other than the point y, at the origin the graph is not there. For all other values, the graph is there. Can you see to the negative axis? The brown color is not touching the negative y-axis. That means for all point, the graph is there. Same way, if you need to check to the negative x-axis, you can see wherever we extend, the graph will not touch the negative x-axis. You can see the brown and black colored lines separately. Can you see the difference? Okay, again, if I am moving it to the right side, positive x-axis, this is the origin. So if I am moving to the positive x-axis, then also you can identify the x-axis and the brown colored graph clearly. That means the graph is not touching the positive x-axis at 0. Same way towards y also. Okay, so thus we arrive at the conclusion that for the domain and range of this function, we have to avoid 0 from real numbers. So here the function f of x is defined from r minus z0 to r minus z0 to r. Domain is r minus z0, range is also r minus z0, but codomain is r. And you must be very sure that when you see this graph you must identify this graph as the graph of 1 by x, and whenever a rational function is defined, denominator will not be equal to 0. Okay. Again, the next function we need is the modulus function. And I will show the modulus of graph of the modulus function. This is the graph of the modulus function. Modulus function, you know the definition. If you want to find modulus of negative 5, it is 5. Modulus of minus 1, it is clear from your graph that minus 1 corresponding y value of minus 1 is 1. Corresponding y value of 1 is also 1. So whenever modulus of negative number and a positive number is taken, modulus value is positive. Okay, so this is the graph of the modulus function. And what about the domain? Domain means you have to find the x values in which the graph is defined, and you can see for all x values the graph y is there. That means the brown colored line is there. Therefore the domain is capital R. What about the range? you are not able to see a brown colored line towards the negative y-axis, and the brown colored line starts from the origin. That means y is taking the value from 0 to to all the points y-axis, to all the corresponding y-axis, the graph is defined. To all the corresponding points on the y-axis, the graph is defined. That means range is positive, y-axis including 0. That means otherwise we can say it is defined for all non-negative values. Okay, so here f of modulus function is a function from f from R to R, defined by f of x is equal to modulus of x. F of x equal to modulus of x, and its domain is capital R, and the range is non-negative real numbers. Okay, and you can see how the modulus sign is written. You can see from the towards the last of the screen, R of x equal to modulus of x. X is written inside 2 lines. That is how we are writing the modulus, and we will read as modulus of x, and this is the graph. So you must identify the graph by seeing, identify which graph is this by seeing the graph. Okay.